The following teacher development program is brought to you by the MultiChoice Africa Foundation.
House.
Careful.
I can't believe the conversation I just had with one of the boys.
What? Who?
You know, Thandi, it's against the law to reveal someone's name. But for now, let's call him Josh. He's going to the clinic for an HIV test.
Oh.
I was shocked by his ignorance. He thinks because he slept with so many girls and he still doesn't have HIV, it's fine for him. I told him, boy, you're playing with fire.
Oh, what does he think his chances of getting it are?
He read that 15% of girls from the age of 15 to 24 are HIV positive. So 15% to him meant low risk. Any thoughts of protection went right out of the window.
You should have done a few sums beforehand. I mean, read like that, statistics and percentages are very misleading. I don't know what we can teach these kids to understand.
Well, it's fine. I mean, this is a killer disease. You know what worries me as well?
Don't tell me it gets worse.
He's had unprotected sex with more than 10 girls over the past 3 years.
Oh, man.
So we've got to do something. We've got to teach these learners to understand what the real risk is. And the question is, what?
I'm with you on that one. Anyway, thanks for the ride.
Okay. Hello?
Hey, are we still on for the game tomorrow?
You bet. My place, 11 o'clock. She's even watching soccer now. I'm starting to really like this lady. Finally a win. So, have you thought about that HIV thing we spoke about? The one we spoke about yesterday?
Well, I thought HIV and AIDS and sex education are a sensitive issue, and some parents don't like it that teachers are discussing it with their children. Maybe you can get away with it by having an informal locker room talk with your team. So tell them about probability and how it's calculated. The probability of an event is worked out like this. I'll show you. Hold that, thanks. Okay. The number of ways an event can occur over the total number of outcomes. Where's your dice?
Dice. Ah, there.
Okay, hold this. I'm gonna show you. Take that one. What are the chances of landing a 3 on this dice?
It's 1/6. My game wins, remember?
And what percentage does that give you?
16%. Let's do this, okay. You divide 1 by 6, and that is equal to 0.16. So because we need percentages, then we have to multiply this by 100, and that gives us 16%.
Good. But Josh didn't just have one partner, he had more than 2. Would that lower the probability of him getting the virus, or would it make it higher?
Well, I'm sure it will make it higher.
Well, how would you work that out?
If 15% of girls in his age groups are HIV positive, I may as well just add up 15% of each and every girl that he has. So that is 30, 45, 60, 75, 90, 105. That surely can't be true.
Fortunately not. If we did it your way, that would mean if you had 7 partners, your chances would be greater than 100%. Your chances can't be greater than 100%.
Okay.
So the most important thing to remember is that you can't add the probability, you must multiply it.
Okay.
Okay. What's the probability of throwing 2 6s in a row? Okay. It's 1 over 6 times 1 over 6 equals to 1 over 36.
Okay, and we do this. 1 divided by 36, that gives us 0.027. So I'll round it off and say 0.03. And that is 3%. Oh, so that means I have 16% chances of throwing a 6 once with the dice. And 3% of doing it twice in a row. Okay, I think we need a refill here.
Most definitely.
Here we go.
Thank you, thank you. I'm time for that.
So when we consider the chances of George staying clean with each new partner, I guess we have to multiply the odds.
That's right.
Let's do the calculations.
What did Josh say again?
Statistics say 15% of girls from the age of 15 to 24 are infected with HIV. So he thinks he has 15% chances of getting it.
Okay, that's right for the first partner, which means there's an 85% chance that he's clean.
And I suppose those odds made him feel pretty confident.
But Josh had several partners, so it changes after 2. As I explained, you multiply the odds. 0.85 times 0.85.
Wait. Why 0.85?
Because 85 over 100 is 0.85. We haven't converted it yet.
Okay.
So 0.85 multiplied by 0.85, 0.72. Then to convert that into a percentage, you multiply by 100, which will give you 72%.
So that means his chances of not getting infected with one partner is 85%. And with 2 partners, it goes down to 72%.
Right. Whereas chances of getting HIV are up from 15% to 28%.
Because 100 minus 72 is equal to 28.
And after 10 partners, his chances of staying clean are down to 20%. So there's an 80% probability that he's HIV positive by now.
I wish we could teach all learners about this in every class. Not just in life skills.
Well, fortunately, kids are learning about HIV and AIDS in their math literacy classes.
Samantha Bruch from Rand Girls High is conducting a simulation in her maths literacy class. She gives each learner clear fluid in a beaker and instructions on a piece of paper. This looks like a science experiment, but actually it is a simulation of how a process happens in the real world. The lesson simulates the spread of the human immunodeficiency virus, HIV. All the beakers contain water except one, which contains a chemical symbolizing the presence of HIV.
You keep your container with your hand firmly at the bottom, okay? When you're swapping, the one person throw this fluid into the other person's container like this, and then the person with this container fill the other person's container half. So in the end, they will have equal kinds of fluids, okay? This is how you swap.
Most of the learners have instructions to swap with as many people as possible and to be as persuasive as possible. A few of the learners have instructions to only swap with one person, while a few learners are told not to swap with anyone, no matter how persuasive they are. Samantha tells the girls to line up to be tested and shares with them what the real purpose of the lesson was.
The experiment that we've done is about AIDS stimulation. So one person in the group was infected with AIDS. Okay? And after the experiment, we're going to say how many is infected. So what we're going to do now, I'm going to do a test, okay?
Samantha will now conduct the tests. Any liquid that turns pink means a positive result. Samantha wants to empower her learners to read and understand the facts and statistics around HIV/AIDS. Since most of these statistics deal with projections about the probability of infection, she begins by discussing with the learners how they were infected in the simulation. All of these girls were told not to swap with anyone, but to have fluid that is tested positive for the so-called infection.
But you were given instructions not to, but you did it anyway. Or did they put so much pressure on you that you couldn't resist that?
Yeah, they did give me pressure because everybody was having fun. I also wanted to have fun.
This group were told to only swap with one person.
Mine said that I should also only swap once, and I swapped twice, of which I came out lucky, so really, it was really scary for me to stand in the queue waiting for my results.
I only swapped with one person, but it still turned to be HIV positive.
So did you learn a lesson that you should follow instructions next time?
Don't be so preachy because you also didn't follow your instructions.
This shows us that if you only do it once with one person, you can still be infected.
Now Samantha introduces the concept of probability.
What is probability? Probability is the measure of how likely an event is. Written as numbers between 0 and 1. 0 means that the occurrence of the event is impossible. Like the one that didn't have to swap with anyone, so her probability will be 0. Then 1 means that the occurrence of the event is guaranteed. We have numbers from 0 to 1.
The learners mark where on the probability line they think various events would fall. Samantha notices that one girl has decided that the possibility of a mother having a girl rather than a boy is very high. She intervenes. Samantha guides the learner into understanding that the chance the baby will be a girl is equal to the chance that it will be a boy. So this means that the probability should be located at the center of the scale, rather than at the ends of the scale as the learner had originally suggested.
A girl, and it's unlikely that it won't be a girl, okay?
Now Samantha looks at the simulation results. First, the learners have to count the number of learners that have clear fluid.
The ones with the clear liquid, can you please hold it up for me so that I can count how many people are you? So 1, 2, 3, 4, 5. So the people with the clear liquid is 5.
The HIV simulation has shown how fast the virus can spread. But how do you quantify this? Samantha demonstrates how to write the probability of picking a person with clear fluid from the whole class as a fraction.
So probability means it is the number of favorable events that occur divided by the total number of outcomes. If somebody comes to the door and you randomly pick someone to swap with, what are the chances that you will not be infected?
Ma'am, I think it would be about 2 out of 10, ma'am.
There was 5 pupils that have not been infected, so it's the possible is 5 out of 34 that's not been infected.
It's 0,147.
This is in the decimal form, 0,147. If I write this in percentage, it will be 14,7%. 7%. That it's unlikely that you will not be infected.
Now the learners have to work out the probability of randomly picking a learner with pink fluid from the class.
Let's just look at our answer. What was your answer on the probability of a person being infected?
It was 85.2%, ma'am.
HIV and AIDS statistics are often quoted in the media and can be confusing. Next, the learners do an exercise in converting expressions such as 1 in 3 into probability fractions and then into percentages.
1 in 3 children born to HIV-positive mothers in South Africa has HIV. How am I going to write that as a fraction?
1/3, ma'am.
From these statistics, the learners have to confront some pretty scary realities.
On this report, it is likely or unlikely, etc., that all of your classmates will attend the class reunion in 2020. Justify your answer.
It was 0.5 decimals, which is going to be 50% of them won't be there. 17 people won't be here. Oh, okay. That's possible.
Although statistics can be an important tool to help us look at trends in society, we must remember that they are only true for very big samples of people. Although 50% of teenagers could be dead in 10 years' time, this does not necessarily mean that this class will share that misfortune.
But if we work out probability is for very large samples. So it does not mean that 17 of these learners in this class will die in 2020. Mostly or likely, most of you will still be alive. Depends on your actions and your attitudes towards sex. If you practice safe sex or abstain from sex, most of you will be here in 2020.
An ordinary maths literacy lesson has become an educational experience that few of these learners will ever forget.
Okay, let's have a look. So if you have 3 partners, 4, 5, and so on, you have to keep on multiplying 0.85 by 0.85 at all times.
And you'll see a pattern. The chances of not being infected will just get lower and lower. I wonder how many partners Lebogang's had. So
Where are you going all of a sudden? I thought you were staying for dinner.
No, I have to get home.
Okay, go if you have to. Yeah, but what about tomorrow?
I'll have to check in my diary. Cheers.
And this talk with unprotected sex and HIV and AIDS made me lose my appetite.